In this video, we'll discuss how to determine the empirical and molecular formulas for compounds. So first off, an empirical formula is the formula that shows the lowest whole number ratio of atoms in a compound. The molecular formula is the actual formula, and it typically can be a multiple of the empirical formula. For example, if you have an empirical formula, CH2O, well, if you just multiply this whole thing by 6, that would give you 6 carbons instead of 1, 12 hydrogens instead of 2, and then 6 oxygens instead of 1. So the molecular formula would be the accurate formula. The empirical formula would be a simplified version of that. And we can determine the empirical formula from the percent composition of, of the compound, or by simplifying the molecular formula like this. If we divided this whole thing by 6, it would give us the empirical formula. But at the same time, the empirical and molecular formulas can actually be the same thing. So when you calculate the empirical formula, we have to start off with the percent composition of each element in that formula. Step 1, change the percent sign into grams for each element. So you're not doing anything other than just get rid of the percent sign and put a G down. Do that for each one of these. Then you divide by the molar mass of each element. Carbon is 12.01, hydrogen is 1.008, oxygen is 15.994, and that'll give you the number of moles. And then you're going to look at those answers. So we have these number of moles here. The smallest number that we had was 1.9719. So we're going to divide each of those by 1.9719. And that'll give you, if you're lucky, a whole number. But you're not always lucky. So we just divide. That gave 2.68 for carbon, 2.68 for hydrogen, and then 1, obviously, for oxygen. So next, in step 4, we really wanted to have whole numbers here because we would use these whole numbers to plug into the formula. So you have to be a little clever sometimes and come up with a whole number that you can multiply all 3 by to get 3 new whole numbers. And in this case, it's 3. If we multiply 2.68 by 3, it'll give you 8, or at least close enough to 8. And then obviously 1 times 3 is 3. So 8, 8, 3, that's our ratio. 8 carbon, 8 hydrogen, 3 oxygen. That's how you determine the empirical formula. It seems like a lot, but really it's not too bad. The molecular formula, it's exactly the same, but with just a couple extra steps. So the first part is to determine the empirical formula. So if we know that we have 39.18% of phosphorus, 60.82% of sulfur, then we can use that to calculate the empirical formula. And then you would calculate the molar mass. So we determine the empirical formula, then we get the molar mass of that empirical formula. In all of these problems, it will give you the molar mass of the molecular formula. So step 3, divide the molar mass of the molecular formula by the molar mass of the empirical formula. So we know the molar mass of the molecular formula is 316.25. We would divide that by 158.124524, and that'll give you a whole number. You take that whole number and you multiply your empirical formula. You multiply the subscripts of each element by that whole number. In this case, P2S3 multiplied by 2, that'll give you P4S6. And there you have it.